All right, so your text has a really good problem in here that usually appears on exams to really mess us up. So here we have capacitors that are put in a combination circuit, kind of like with resistors where you had combination parallel series. Well, how do we treat capacitors, which is a complex battery that we use to smooth AC currents? How do we treat them when they're in combination circuits like this? Okay, so how do we resolve? So here the question says, find the charge and the potential difference across X, Y, and Z, each component, when each of them has 12 picofarad capacitance, and this is the voltage of the battery in the circuit. Okay, well, similar to when we were working with resistors, we want to take this combo and make it into something that we know how to solve. So I redrew it. I put the 12 picofarads as the capacitors. I labeled it X, Y, and Z. And I want to convert it into something that would be easier, which is just either a parallel circuit or a series circuit. And it would be easier for me to convert this into a series circuit, similar to what we did with resistors. So step number one is to convert that parallel circuit into a series, okay? So I have to distill this out. So I'm gonna turn this into a quasi-capacitor of its own. This is a parallel circuit, so how can I treat that? Well, the total, C total of a parallel is equal to C1 plus C2. So that's easy. So 12 plus 12. This is 24 picofarads, and this is 12 picofarads, X. Okay? So the first step that I'm going to do is I'm just going to try to solve everything I need to solve here. And then after doing that, it would give me what I need to solve for over here. Okay, so what I do know in a series circuit is that Q total is equal to Q1 plus Q, no, not plus, which is equal to Q2. So it's the same. So the Q that is going to be here is the same that's here, and that's also equal to Q total, okay? So I'm going to try to figure that out. All right, how do I do that? Well, to find the total charge on this bad boy over here, I need to find the Q total. In order to do that, Q total is going to be equal to C total times V total. Okay, so Q total is equal to, we got to get the C total, right? So C1 over C total is equal to 1 over 12 picofarads plus 1 over 24 picofarads. Okay, what does that become? 1 over C total is equal to 3 over 24 picofarads. If I flip that over, C total is going to be 8 picofarads. So 8 picofarads times 12 volts is going to be my Q total. Q total is equal to 8 times, now pico, if I search up in my data booklet, I think is 10 to the minus 12 farads, okay, times 12 volts, okay, and then that should give me my total charge. So if I do this in my calculator really quick, 8 EE12 minus times 12 gives me 9.6 times 1. Okay, so that's my total charge, okay? So the question, again, if I go back to it, says find the charge and the potential difference across each capacitor. So we have the charge across each of these. This is the real capacitor, this is quasi. So I have the charge across this. I have its actual capacitance. So I should be able to solve for the voltage across that. So let's try to do that. So the voltage across X of X is going to be equal to Q total divided by the capacitance of that component, okay? So then Q total, we said, was 9.6 times 10 to the minus 11 coulombs divided by 12 picofarads, so 12 times 10 to the negative 12 Put that in your calculator. And that, oops. Okay, 9.6 EE 11 divided by 12 EE 12 gives me 8. Okay, so that's 8 volts. Okay, which then leaves me with 4 volts. Okay, so I would have 4 volts here. I would also have 4 volts there because they're parallel. Okay, so there's 8 volts, oops. There's 8 volts across X, and I would have 4 volts across the other two components, or I'd leave it as 4 volts. And then to solve for the total, to solve for the charge that is here, I should be able to get, I should be able to get this no problem, okay, by solving this. So 4 volts times 12 picofarads, 4 volts times 12 picofarads would give me the charge on Y and Z, all right? And that's how you would go about solving this problem.